Hi, everyone. My name is Vanessa Zobel, and I'm a third-year PhD student at Scripps Institution of Oceanography. And today we're going to be going over lesson number 2 on ocean acidification. Just a little bit about me. Like I said, my name is Vanessa. I'm in the Scripps Whale Acoustics Lab, and I listen to whales, mostly humpback whales. I listen to them sing underwater, and that's how I monitor where they are, how many there may be, and what threats they're facing today in the ocean and how to keep those animals safe. Just a review about what we learned during lesson 1 in ocean warming. We learned that carbon dioxide concentration in the Earth's atmosphere has increased over the past 100 years, and so has the ocean temperature. And we know this because scientists have been constantly measuring the temperature of the oceans using boats and systems called Argo floats, those robots that we saw. The graph here shows the sea surface temperature that has been rising steadily at about 0.1 degrees Fahrenheit per decade. And the warming temperatures of the ocean has made hurricanes stronger and has affected the health of coral reefs and other sea life. Today, we're going to learn about how the absorption of carbon dioxide by ocean water causes the ocean to be more acidic. So the questions that will guide us today, we'll learn what the words acidic and pH even mean. We'll learn how we can measure acidity using the pH scale. We'll learn how adding more carbon dioxide or CO2 to the air can make ocean water more acidic. And we'll also learn how ocean acidification has impacted marine animals that need carbonate ions to make shells, and how marine food webs have been impacted by ocean acidification. So pH is a way that we measure acidity of a fluid or a solution. And we measure pH from 0 to 14, with 0 being the most acidic and 14 being the most basic or alkaline. Lemons are about 2, and they are very acidic, and soap is about 10 because it's basic. pH is determined by the concentration of hydrogen ions or H+ ions, and acidic solutions have a lot of H+ ions, and basic solutions have less H+ ions. So a lower number on the pH scale means that if it's more acidic and it has more H+ ions, then it will be lower on the pH scale. A pH indicator is a substance that changes color based on the concentration of H+ ions or hydrogen ions in the solution. pH strips or paper strips are used to test the pH of your local swimming pool or your hot tub, and it's helpful because it's a visual way that we can determine the acidity of a solution. So the ocean or seawater on the pH scale is actually a little bit more basic than pure water, which is at 7. So the ocean is at about 8 on the pH scale, and ocean plants and animals have adapted to thrive in that very specific pH of 8 of the water that they live in. And if it becomes more acidic, then they may have to adapt, or they may be in a little bit of trouble. So now we'll move on to an experiment. Now we're going to do a little experiment that shows how carbon dioxide affects the pH of water. Purple cabbage actually contains a pigment that is a natural pH indicator. And I extracted the pigment by chopping up the cabbage, mixing it with some hot water, and putting it in the blender. So the blue juice that we get from the cabbage and water mix has a pH of 7 because it's just tap water from the sink. So it's nice and blue. So next we're going to be putting a couple of deep breaths into this mixture, and our breath contains carbon dioxide or CO2. Do you think that blowing our breath, which contains carbon dioxide, will make the blue juice turn a color? And if so, what color do you think it will turn? More acidic, like purple and pink, or more basic, like green? You can pause right here and talk amongst yourselves. Okay, let's see what happens. 10 breaths into the cabbage juice. Okay, so after blowing a couple of breaths of cabbage juice in or of carbon dioxide into the cabbage juice, you can see now and here's the original. It did change color a little bit from the original. The original is still that pretty dark blue, and now we have some more purpley color. So just for fun, let's see what happens if we put a bunch of lemon in the cabbage juice too. And remember, lemon is very acidic. It got even more pink, hot pink now. So now this pH indicator is letting us know that this indeed is an acidic solution. So what does this all mean for our experiment and for the ocean? So why did this solution become more acidic when breathing carbon dioxide into it? Well, the carbon dioxide in our breath combined with the water in the cabbage juice to form an acid called carbonic acid, causing the pH of the solution to drop and the cabbage juice to turn more purple in color. And this is interesting because about a quarter of the carbon dioxide or CO2 released by activities like burning fossil fuels, driving our cars, factories, is absorbed by the ocean. And as a result, the ocean has become more acidic, like the cabbage juice in the experiment. And over the past 300 million years, the ocean's pH has been about 8.2. But today it's at about 8.1, which may not seem like a big decrease, but due to the nature of the pH scale, it's a logarithmic scale, and a 0.1 decrease is actually about 26% increase in acidity over the past 2 centuries, which is a lot. So Erica will be discussing more about ocean acidification and how it affects the environment in part 2 of this video. Thank you guys so much.